Now comes ideal solution and non-ideal solution. Ideal solution means it is a solution in which each component, that is the solute as well as the solvent, obeys the Raoult's law over the entire range of concentration. When it obeys the Raoult's law, then it is said to be the ideal solution. When it deviates means then that refers to the non-ideal solution. So practically no solution is ideal over the entire range of concentration. Practically no solution is ideal. எதுவுமே ideal அப்படி சொல்ல முடியாது ஏன்னா எல்லா சொல்யூஷனுமே ரவுல்ஸ் லா ஒபே பண்ணும் அப்படின்னு சொல்ல முடியாது. That gets deviated. Actually when the concentration of solute is low, then the dilute solution behaves ideally. And also if the two components present in the solution A and B are directly or identical in size, structure and having almost similar intermolecular attractive force between them. Suppose if we take AA, BB and BA, then their intermolecular force of attraction will get changed. That is, they will behave ideally in different manner. That entirely depends on their intermolecular force. So for example, if we take an ideal solution, there is no change in the volume on mixing the two components, especially the solute and the solvent. So the delta V mixing will be equal to 0. So no change. It won't have any change. அதே மாதிரி there won't be any exchange of heat when the solute is dissolved in the solvent. So delta H mixing will be equal to 0. So mixing will be equal to 0. In the இடத்துல வந்து and delta V that refers to the volume. So volume எந்த சேஞ்சுமே இருக்காது. ஆனால் அதனுடைய delta H mixing will be equal to 0. And also escaping tendency of the solute and the solvent present in it should be same as in pure liquid. So escape tendency வந்து பார்த்தீங்கன்னா that will remains the same. For example, if we take benzene and toluene, அதே மாதிரி N-hexane, N-heptane, ethyl bromide, ethyl iodide, chlorobenzene, bromobenzene. So இது ஆல்மோஸ்ட் எல்லாமே சிமிலராக இருக்கும். ஆனால் எதனாவது ஒரு டேர்மில் வந்து பார்த்தீங்கன்னா it gets changed. Okay, so now comes non-ideal solution. So if we take a non-ideal solution, here the solution does not obey the Raoult's law and also that will get deviated. Okay, so our entire range of concentration எதுவுமே வந்து obey பண்ணாது. அதுதான் non-ideal solution. So எல்லாமே வந்து பார்த்தீங்கன்னா almost non-ideal இருக்கும் because there is a change in the volume and also enthalpy on mixing. That is delta H mixing is not equal to 0 and delta V mixing also not equal to 0. So now the deviation of the non-ideal solution from the Raoult's law can be either it will have a positive or else a negative value. It won't have the same value, whether it may be a positive or else a negative value. So that refers to a positive deviation and also a negative deviation. So actually that will be given by two forms. One is the positive form and another is the negative form. So let us see the explanation for those along with their example. So now let us see the example for this. That is alcohol and then ethanol, ethyl alcohol. So this refers to the positive deviation. So at one axis we have to take vapor pressure and in another axis we have taken mole fraction. Okay, so this diagram refers to the vapor pressure diagram showing positive deviation. Okay, so the X here refers to the mole fraction of a pure solvent A and XP refers to the mole fraction of a pure solvent B. Then PA naught that refers to the partial pressure of the component A. Pure partial pressure. Okay, pure component A. Right? So now the pressure, total pressure will be given by PA and then PB. The sum of both the partial individual partial pressure and also on plotting their value here they get deviated with one term to the another term. Okay, so one component refers to alcohol and another component is ethanol water. So if இங்க ethanolக்கு then water and then the total pressure is given. So அதனுடைய வேல்யூஸ்லாம் வந்து பார்த்தீங்கன்னா ஆல்மோஸ்ட் ஒரு ஸ்டேஜ் ரைஸ் ஆகிட்டு அண்ட் அகெயின் அது ஒரு ஈக்குவல் டேர்ம்க்கு வந்துச்சு. தட் இஸ் ஒரு காமன் டேர்ம்க்கு வந்து they get settled down. அதே மாதிரி டோட்டல் ப்ரெஷர் வந்து பார்த்தீங்கன்னா ஆல்மோஸ்ட் சிமிலர் வேரியேஷன் இருக்கு. Now if we take a negative deviation, here the example is simply acetone chloroform and then chloroform diethyl ether, acetone aniline, then chloroform benzene. ஏதாவது இந்த ஃபார்முலா we have to take, and along with that when we plot its value, by the time what happen, it gets deviated in negative form. So அப்படியே ரிவர்ஸ் முன்னாடி எப்படி வந்தது பார்த்தீங்கன்னா it moves in a positive way, ஆனால் இதில் வந்து பார்த்தீங்கன்னா it starts with 0 and it gets changed over along the negative form of deviation. Okay, here this dotted line refers to the ideal behavior and solid lines. So in the green, blue, red color line there, that refers to the actual behavior. So actually on the compound எப்படி வந்து deviate ஆகுது பார்த்தீங்கன்னா இந்த டைரக்ஷனில் இருக்குது. ஸோ அது லைன் ஃபார்மில் போட்டு ஐடியலாக எப்படி இருக்கும் நான் ஐடியலாக எப்படி இருக்குன்றது தான் they have given here. Okay. So now let us see the factors responsible for deviation from Raoult's law. So factors on the pathina, here three factors is given. One is solute, solvent. Next is the dissociation, and then association, and also temperature, pressure, concentration. அப்படினு so totally 6 factors இருக்குது. So first வந்து பாத்தீங்கன்னா solute solvent interaction, then dissociation. So solute solvent அதுக்குள்ள interaction. ஸோ நமக்கு ஆல்ரெடி ஐடியல் நான் ஐடியல். ஸோ ஐடியல்ன்றது ஒபே பண்ணும், நான் ஐடியல்ன்றது இட் ஓன்ட் ஒபே திஸ் ரவுல்ஸ் லா இல்லையா. ஸோ சொல்யூட்டும் சால்வெண்ட் கான்சன்ட்ரேஷன் அப்படி இருக்கும்போது we have taken an example AA, அது வந்து molecules, BB வந்து solute molecules. So here totally we can tell they seems to be similar, right? And also there will be a deviation from the ideal behavior. So this refers to their deviation. Then comes the dissociation of solute. Here we can take the example potassium chloride along with water. Here K plus Cl minus. Okay. And again for H2O, H plus OH minus. That refers to the dissociation. Okay. Actually this entirely dissociate the ion concentration, that is their constituent ions, and also this will cause deviation from Raoult's law. Now comes association of solute. Here the association of solute molecules can also cause deviation from ideal behavior. For example, in solution acetic acid exists as dimer by forming intermolecular hydrogen bond, and also they will get deviates from the ideal behavior, that is the Raoult's law. So if we take acetic acid, it is a dimer, it will form intermolecular hydrogen bond, and also that will get deviates from the Raoult's law. See, actually this refers to the acetic acid. So acetic acid எடுத்தோம்னா அதனுடைய ஃபார்முலா வந்து CH3COOH இல்லையா. ஸோ இப்போ ஒரு moles of acetic acid and here another moles of acetic acid, இதுலேருந்து ஒரு இந்த டபுள் பாண்டில் இருக்கக்கூடிய O and then இந்த ஆசிட்ல இருக்கக்கூடிய ஹைட்ரஜன் will form one intermolecular. So intermolecular hydrogen bond வந்து இட்ஸ் a weak bond. ஸோ அதுவே ஒரு மோல்ஸும் இன்னொரு மோல்ஸும் இந்த மாதிரி ஃபார்மில் தான் கனெக்ட் ஆகும். ஸோ அது இதுலேருந்து ஹைட்ரஜனும் இந்த காம்பவுண்டில் இருக்கிற டபுள் பாண்ட் ஓ இது ரெண்டும் will form a dimer bond like this. Okay, now comes temperature, pressure, concentration. So temperature, if we increase the temperature of the solution, then that lead to the increase in their molecule. Okay, so the energy, molecular kinetic energy change occur. Actually that leads to the ideal behavior. It takes place from ideal behavior. Again, if we increase the pressure, that also increase the molecule intermolecular attraction, and also concentration. If we increase the concentration, that leads to the increase in the concentration of the solution also. So if solute and solvent concentration increases, then the solution concentration will also get changed. So this also deviate from the Raoult's law.